Welcome to another episode of Terry's Notes, and today we're going to be looking at the June 2017 paper, question 2. Okay, so question 2, part A, part 1. The question says to factorize the following expression completely. So in part 1 we have 6y squared minus 18xy. Right? How do we factorize this? So we have two expressions here, two terms, 6y squared and 18xy. So the first thing we need to do, we need to find the HCF of 6 and 18. So the highest common factor of 6 and 18 is 6, right? Then we have a y squared term in the first part here, and we also have a y in this in the second part. So therefore the HCF of y squared and y is actually y. The first term doesn't have an x in it, so we can't take out the x. So it'll be 6y, open brackets. This will be y, because 6y multiplied by y will give me y squared, minus 6 multiplied by 3 will give me 18, and we have to put an x here. So therefore when we factorize 6y squared minus 18xy, we end up with 6y, open brackets, y minus 3x. Now we can easily check our answer by just removing the brackets. So 6y multiplied by y minus 3x, right? If we use the distributive law, we take the first term and multiply by, we take 6y and multiply by y, we end up with 6y squared. Then we take 6y and multiply by minus 3x, and we end up with 6 3s are 18xy, right? Which is the same as this here. So we know that when we factorize, this is our answer here. 6y, open brackets, y minus 3x. Then for part 2, the question asks us to factorize 4m squared minus 1. Alright, just by looking at this, we can tell it's a difference of two squares. So what we do, we write this as 2m squared, because 2m squared will give me 4m squared, minus, and we can write this as 1 squared. So all I'm doing is writing it as a difference of two squares. Now, when we have a difference of two squares, so if you have something like this, this is the difference of two squares. We know that that is equal to a plus b into a minus b, right? This is something that you need to learn, right? So the difference of two squares, and when we say two squares, so we have a squared and we have b squared. That can be written as a plus b in brackets, open brackets, a minus b. So this is something that you have to learn. So what I've done with 4m squared minus 1, I have written it as the difference of 2 squared. So therefore, when I factorize, I will get 2m plus 1, and the other bracket will be 2m minus 1. So that is how we factorize 4m squared minus 1. So the third part now, which is 2t squared minus 3t minus 2, and we want to factorize this. If we look at this, we can easily tell that it's a quadratic expression because we have a squared term, right? Because of this term here, we say that this expression is a quadratic expression. So in order to factorize a quadratic, we need to find, first thing we need to rearrange this, right? So what we are doing is replacing the middle term in the quadratic, which is the minus 3t, and we are replacing it with two different terms. So we are looking for two numbers whose sum is equal to minus 3 and whose product is equal to 2 multiplied by minus 2, which will give me minus 4. Right? So let me just backtrack a little bit here. When you have an expression in the form ax squared plus bx plus c, we can replace this middle term here, the bx, right, by finding two numbers whose sum is equal to, in this case, b, and whose product is equal to a c, right? So this is something that you have to know as well, right? Now, right, so I have the sum as minus 3 and the product as minus 4. So what two numbers could that be? So it can be, let's see, 1 by minus 4. Was that correct? 1 multiplied by minus 4 will give me minus 4. And 1 minus 4 will give me minus 3. Okay, so I'm going to replace the middle term. So 2t squared. And when I'm replacing the middle term, what I'm doing, I'm saying plus 1 or plus t minus 4t, right? I got this t from this 1 here, and I got this minus 4t from this here, right? Because I'm finding two numbers whose sum is minus 3 and whose product is minus 4, right? And then I have to put back my minus 2 here. So all I've done from this point here to this point here is replace this term, right? Now I can go ahead and factorize by grouping. So if I look at the first two terms, I can pull out t. So this will be 2t plus 1, right? And then I'm going to put, let's see, I'm going to pull out 2 here. And this will be 2t plus 1, right? Because when we are grouping, we need to get the brackets being the same. So this should put a minus sign here, right? So therefore the final answer will be 2t plus 1 into t minus 2. All right, and that is how we factorize that quadratic expression, right? I know for some students factorizing a quadratic can be difficult, but with some practice you can get this very easily. Now we are looking at what is this, part B? Okay, so in part B, they give us an expression and they want us to write it as a single fraction and simplify. So the expression is 5p plus 2 over 3 minus 3p minus 1 all over 4. Alright, so in order to simplify, once we have two fractions, because we have two fractions here, first thing we need to do is to find the LCM of 4 and 3. The LCM of 4 and 3 is 12. So I'm going to draw this line here, and I'm going to put 12 at the bottom. Right? So 3 can go into 12 4 times. So what I'm doing is taking 12 and divided by 3. I'm going to get 4. So I'm going to put 4 here, and then I have to multiply it by 5p plus 2, close brackets. I have to put back this minus sign here, so minus. Then I'm going to take the 12, so the 4 can go into 12 3 times. How did I get that? 12 over 4 will give me 3. So this is 3, open brackets, 3p minus 1. Now I need to simplify this. So I'm going to use my distributive law. So take the 4 and multiply by the 5p, which will give me 5 4s are 20p. Then the 4 by the plus 2 will give me plus 8. Then minus 3 by 3p will give me minus 9p. And I'm going to take minus 3 and multiply by minus 1, which will give me plus 3. And then all of this will be over 12. Right? So we deal with the terms in p. So 20p minus 9p will give me 11p. And 8 plus 3 will give me 11 all over 12. Right? So they want this as a single fraction. Right? So since we have 11 on top, we can either leave our answer like this, or we can put 11 open brackets p plus 1 all over 12. Right? All I did was factorize the top part. Nothing complicated there. Okay, so